So fractals, I used to think fractals were scary until I actually learned about them. I thought they were scary because they were like this mysterious thing that people talk about as being like this cool, complicated, like infinite thing. But then when I actually kind of looked at them and started seeing the pictures and got a feel for like some of the basic examples, I realized they were not nearly as scary as I thought they were. They're actually like, in my opinion, not really too like they're definitely not like the most complicated thing that we do in like even this class. In my opinion, I think so far probably arithmetic in different bases might be the hardest thing. Um, Fractals are just a lot of really cool pictures. So let's get to some pictures and some examples. So I'm just going to kind of show you some examples, and then maybe I'll just generally define fractals. Okay, so the Koch snowflake is one of like the most famous examples. Technically, what I'm about to draw is not the Koch snowflake, it's the Koch curve. Um, but I'll show you the Koch snowflake as well. I don't know if I'm pronouncing that name right, so sorry if I'm saying it wrong, but whatever. Okay, so we're going to have a stage 0, which we're going to call like an initiator, and a stage 1, which we call a generator. All right, that terminology means nothing, just follow the pictures. All right, so our stage 0, this is just like what we start with. So to draw the Koch curve, we start with just this line segment, okay? And then after we start with that line segment, we then replace that line segment with this picture, which is, so we think of the line segment as like broken into like 3 little line segments here, kind of like so. And then basically we get rid of this line segment and then replace it with like the top half of this triangle up here. So that's what we do to go from stage 0 to stage 1. To go from stage 1 to stage 2, we basically repeat the same thing. So notice here that in stage 0, we just had this line segment. In stage 1, we now have 4 line segments. And from stage 0 to stage 1, think of that as every time I saw a line segment, I replaced that line segment with this picture. From stage 1 to stage 2, we're going to do the same thing. Every time we see a line segment, and there's 4 of them, every time we see a line segment, we're going to replace it with this picture. So I'm actually just going to copy and paste this picture. And then I'm going to do this a lot, actually. So let's see if I can do this on the fly. All right. So this first line segment right here, let's get rid of that and replace it with that picture. Okay? Actually, you know what? Let's make sure that they're all the same size just by copy and paste this one from now on. Okay, this line segment right here, I'm going to get rid of that, and I'm going to replace it with that same picture. It's going to be kind of messed up. This is like slightly not the right size, but whatever, bear with me. So this is what we got so far. All right, let's get rid of this guy and then replace him with one of these as well. Boom. So that's what we got now. And then again, this last line segment, get rid of that, replace it with that. And so this is our stage 2. Okay, so to go from stage 0, which is you start with that line, to stage 1, just replace the line segment with this picture. Stage 1 to stage 2, replace each of these line segments with that same picture. In other words, we for each line segment, we replace the middle third of it with like the top half of that triangle. Okay, so you could also just kind of like go and boop, 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 just like that. Okay. To go from stage 2 to stage 3, if you really understand stage 1 to stage 2, then like you pretty much understand the whole gist of it. from stage 2 to stage 3, what's going to happen? Well, now I have even more of these line segments. I'm not going to count them, but I have a lot of line segments. And each of those line segments I'm going to replace with this picture. Okay? So, yeah, it's going to get kind of complicated pretty fast. So I did it ahead of time. And this is going to be what it looks like. So this line segment here, replace it with that picture. This line segment here, replace it with that picture. This, this one here, this one here, this one here, replace each of those with that little picture. And you just keep doing that for every little line segment, and eventually you get something that looks like this. And so the Koch curve, again, this is really not the Koch snowflake, this is the Koch curve. The Koch curve would be stage like infinity of this process. Just like do it forever and ever and ever. And like at a certain point, like, you know, if you're like zoomed out this much, you're not like gonna be able to like see all the fine details. Like the pointed parts of like each of these little snowflake parts is like getting smaller and smaller and smaller, like each stage that you draw. And so eventually like the details just become so incredibly tiny that you can't really see them. So like, you know, drawing stage like 10 or 12 or 15 or 20 even, like will be like more than enough than you need to really get a picture of like what the whole thing's gonna look like. All right, let's actually talk about the Koch snowflake. It's not so different from the Koch curve. Koch curve, we start with a line segment and then replace each line segment with the little triangle pointy thing, right? Koch snowflake is, instead of starting with a line segment, we start with a triangle, and then each of the sides of the triangle we're going to replace with that little pointy triangle thing. So replace this with that, replace this line segment with that sort of picture, replace this line segment with that sort of picture. You can kind of tell that like my picture's like a little bit off, like the angles are not perfectly good, but hopefully you get the idea. And I'm not going to do this one in as much detail as the previous one, but I did it ahead of time. And so if you look at what stage 2 and stage 3 kind of look like, again, you are going to replace like each of the line segments with this little curve thing. And then, you know, now we have like, what is it? Like 12, you got 12 line segments here, and replace each of those line segments with the little pointy boy. And then you just kind of keep doing that indefinitely. Go from stage 2 to stage 3. It'll be really similar. This is what stage 3 looks like. And if you were to repeat this process indefinitely, or infinitely or whatever, you get the Koch snowflake. So this is like stage infinity. It's probably not actually stage infinity. It's computer generated. They probably stopped at stage like, I don't know, 10, 20, 30. Like you zoom in, like there's only so much detail that the computer is able to generate. And so after a certain number of stages, the computer, like it's just not worth it for the computer to generate any more stages. But in theory, the Koch snowflake is just like repeat the process like infinitely many times. Okay, so these are examples of fractals. A fractal is an object which is created iteratively, usually having some level of self-similarity. This is not a very formal definition or whatever. It doesn't have to be. But like, you know, anytime that you create something with this sort of process, like you're going to get a fractal. So this right here, these are like the first 5 stages of like this fractal, which is like pretty similar to the Koch snowflake. This right here is literally the Koch snowflake, just better picture of it. This is Sierpinski's carpet. This is Sierpinski's triangle, otherwise known as Sierpinski's gasket for some reason. I don't really understand the terminology. Maybe it's a quick Google search, but I don't know. This over here is a really cool picture. I think it's called the Mandelbrot set. I think it has something to do with like complex analysis. I won't talk about like this one like at all. I just think it's a really cool picture. So fractals can like give you some like really cool pictures going on. But you know, notice the self similarity going on with it. Like it has like a lot of patterns going on with it. Like this part. Let me. Can I do? Yeah, green shows up a little better. Yeah, like this little nubby thing right here is like the same as this little nubby thing right here, just kind of scaled down. This is the same thing, scale down, scale down, scale down. So there's like a lot of self-similarity going on with it. All right, let's do like a simpler example of a fractal. So family tree. So we'll have our stage 0, our initiator, and then our stage 1, which is called our generator. I'm gonna go back to blue. Okay, so our initiator says we just start with this line segment, and then our generator says anytime that you see a line segment just going straight down, just attach on this little family tree sort of thing. Okay, so notice that these line segments are going to be like about half as long as that line segment that they were attached to. So to go from stage 1 to stage 2, now I have these 2 line segments down here, which I'm going to attach like that sort of picture onto. Okay, so I can do that. Except I have to kind of shrink it down a little bit. So it has to be like half the size. So I do this, and then this would be my stage 2. And now to go from stage 2 to stage 3, well, now I have these 4 little nubby things. And so when I go over here and touch that, so zoom in so I can actually make this picture. Alright, that's good enough. It's about half as big. So now I have like the picture is like half as big. Notice that like these things are like kind of scaling down too, like in each stage from this stage to this stage, from this stage to this stage. Like the things that we're iterating, there's scaling down, like they're getting smaller and smaller and smaller. So the details are becoming like more and more like tiny, I guess, as each stage goes on. That is not necessarily a part of fractals. Like they could always be the same size, but generally when people do fractals, usually like the stages, like when you iterate each successive stage, like the thing that like you're tacking on gets like smaller and smaller. Okay, so yeah, you can probably get the picture of like what this thing's gonna keep looking like. You just sort of keep on tacking on the little family tree thing and then just kind of indefinitely add those on. So that's another example of a fractal. Here's the box curve. So the box curve has your initiator is just a straight line, and then your generator would be every time that you see this line segment, replace it with the little box curve. Okay, so let's go from stage 1 to stage 2. So we start with that picture, and then we're going to replace each of these line segments with a little box curve. Okay, so I'm going to copy and paste that again, and I want to make it, sorry, I'm like zooming. I try not to zoom in and zoom out so much when I do these videos, but I kind of have to if I'm doing these pictures on the fly here. So, okay, let's just delete that and place it with this. And then I'm going to do that over here as well. Maybe I shouldn't have done that actually. I'm just going to do this. All right, delete that. kind of hard to draw, but okay. So these two things should technically like be like touching each other. Ooh, I know how to do this actually. Boom. Boom. Stop it. Okay, there you go. And then I'm going to do the same thing for the top part of the picture. And then similar thing over here. Get that going on, and then don't worry, I'll fix it in a second. And then we'll do this over here. But of course, this should be kind of shifted over here like that. So it looks like this. So here on this side, you got that little picture. Here on this side, you got that little picture, and then you got that picture down here. You got that picture over here and here and here. And they just so happen to be like touching right there. So it gives you like this cool little pattern. It looks like it's like doing a little spiral there in the corners, although that's not exactly what's going on. All right, and stage 2 to stage 3. I know how to do this. All right, do that. I'm just gonna give a rough picture. It's gonna look terrible. Okay. Stop it. Please cooperate. Please cooperate. Okay. Good enough. Okay, so that's gonna be that. And then, no. And then we're gonna have similar thing. I wanted that. Okay, so I copy that. I paste that for the top half of the picture. You're on YouTube, you can just skip me doing all this stuff anyway. And then we'll have one down here. And then we'll have one over here. I'm definitely kind of cheating in my process a little bit here, but you know, this is basically what the final picture is going to end up looking like. Okay, so yeah, so basically, so technically, yeah, like at each of these curves, I should just be replacing this with and then replace this one with but if you do all that, you end up getting a picture kind of like this. For a prettier picture, you can kind of go into the textbook and see what that looks like. Anyway, this picture's terrible. Ignore it. Canner set, I can definitely draw good pictures of this one. All right, so here's what you start with. You just start with a line segment. And here, instead of like copy pasting stuff, you're actually going to be removing stuff. So you start with this line segment. And then what you're going to do, split this line segment into 3 little line segments. And then what you do with that, to go from stage 0 to stage 1, you just replace that middle line segment, or you just remove that middle line segment, rather. Okay, and now you have 2 line segments. What do you do with that? Well, each of these line segments, you remove the middle third. So to go from stage 1 to stage 2, all we're going to have to do is remove the middle third of each of those line segments. So I'm gonna do it like this. So make it look like that. And this one, well, I might as well just, oh, not save. Copy and paste that, put that over there. Okay, cool. That's stage 2. Stage 3, now I have 4 line segments. And then each of these, I'm going to remove the middle third of that. Okay. And so if I were to do that, what would that look like? So removing the middle third from these two things, removing the middle third from this one would give you the thing right below it. Removing the middle third of this guy would give you this thing right below it. Removing the middle third from this guy would give you this. Removing this guy's middle third would give you this. And so this would be our stage 3. And you just continue this process indefinitely, and then you would get your canter set. You might already kind of be picking up on the fact that this, like at stage 3, it looks like there's like nothing in there, right? So the canter set's really weird in the sense that like if you were to repeat this like indefinitely, it would look like there was like almost nothing there. So it would be like just like almost completely empty. What's weird about it is that there's still going to be like infinitely many things in there. There's like a lot of weird math that is happening in the canter set. George Cantor, he did a lot of research on this set, and a lot of cool results came out of it. Okay, here's the Sierpinski gasket or Sierpinski triangle. I put it up here, like just I don't know why it's called gasket, but it is. So you start with a triangle, just like a filled-in triangle, and then you remove like the middle triangle from it. Okay, and so to go from stage 1 to stage 2, that looks so cool. You just take each of these triangles and then remove like the middle triangle from that. And so if I were to kind of draw what that ends up looking like, I can kind of cheat a little bit and just make it like this. And then to go from stage 2 to stage 3, I can again just kind of cheat a little bit and then just take 4 of these guys, 3 of these guys, and just copy and paste them. And so yeah, effectively what I'm doing has the same result of just removing the middle triangle from each of these guys and then removing the middle triangle from each of these guys. The Sierpinski carpet is pretty similar. Spoilers. Sierpinski carpet is pretty similar. You start with your generator. It's just going to be a filled-in box, and then to go from stage 0 to stage 1, every time you see a filled-in box, you replace it with this pattern right here. So you have like 3 filled-in boxes over here and 3 down here. There's like a lot of different variations on what this could look like. So like the classic one is like only missing the one in the middle. But like this could look in any number of ways. So this is what I kind of went with here. And so if you were to go from stage 1 to stage 2, every time I see one of these filled in boxes, I'm going to replace it with this thing. Okay. And so let's copy that. So in the top left, I'm going to have one of these filled in boxes. Right, I'm going to replace that top left thing with this picture. I'm going to replace the top middle one with that picture. The middle left one with that picture. The bottom one. The right middle. And then the bottom right there. And then on the sides, like these corners like won't really have anything. So maybe let's just bring that over here. Bring that down here. Cool. And then so that would be your stage 2. Can I do this? Yeah, cool. Okay, so yeah, that's your stage 2. And then your stage 3, it's going to be really similar. Let's just do it. I just feel like doing it. If you oh no, it's not snapping anymore. Oh well. There's too many details going on for it to be able to like snap anymore. But yeah, it's still gonna look quite similar in spirit. So it'll look kind of like this. So again, I'm like kind of cheating when I'm doing this, and yeah, I know I'm like kind of like falling off the screen right here. That's not a YouTube thing. That's just like I ran out of space here and I kind of gave up on the drawing. But yeah, so yeah, same idea of like I'm doing like cheating copy paste tricks just because like there's so much self similarity with fractals that you can kind of get away with doing that copy paste trick. But really from like one stage to the next stage, I do want to emphasize that what I am always really doing is, replace the filled in thing with that sort of picture. So I replace this guy with that picture. I replace this guy with that picture. And then same thing from here to here. Now this top left picture right here, that top left box gets replaced with that that 9x9 little pattern. This box right here gets replaced with that pattern. This one doesn't get replaced with anything because it's empty. It's just empty space. This one right here gets replaced with the pattern, and so on. Yeah, and so that's pretty much it. Oh, I see. You can kind of see you can kind of see like the rest of the pattern that I was drawing up there. It somehow flew into the next slide. Whatever. Okay. Fractals are really pretty. So these are just some pictures that I found on the internet. I just went to Google image search and just typed in fractals, and these are some of the pictures that I got. I don't even know what most of these things are. This one just looks like a nature thing. Like fractals and nature are very intertwined. Fractals just, self-similarity sort of things just happen in nature all the time. Like nature's beautiful, like all that good stuff. I don't know what this is. They just kind of look cool. And yeah, fractals, there's a lot to know about them. There's a lot that you could kind of do with them. They're just really pretty, really cool thing. Yeah, so not too much to say about it. Hope you enjoyed this, and see you in the next one.